Hello, I'm David Kolosche from the University of Klagenfurt in Austria, and this is my presentation of my paper How Post-Factualism Creates New Needs for the Epistemology of Mathematics for the 11th MES Conference. I will first ask why I should be bothered about this. Then, second, I will look at mathematics education research on post-factualism. Third, I will describe the connections between post-structuralism and post-factualism. Fourth, I will argue that we need some kind of epistemological education in the mathematics classroom. And fifth and last, I will propose that the styles of reasoning framework might be a possible solution to this problem. So why should we bother? Well, of course, we have all experienced some kind of post-factualism in the last years. And you might ask, what does mathematics have to do with that? Well, as the tip of the iceberg, I want to present two episodes to you. The first one is a short film called Alternative Math, where a student refuses to accept that 2 plus 2 is 4. And the whole thing becomes very public and attracts a lot of attention. And in the end, the teacher is fired because she wouldn't accept that 2 plus 2 could be anything else than 4. The whole thing is only a parody of the post-truth movement, and still it brings to the public attention the question whether even mathematics could be open to alternative truths, to alternative facts. The second episode is a Vogue Mini, which is just a picture which is posted to Twitter by James Lindsay. Lindsay is a critic of the US-American social justice movement, and he does some of his criticism by posting these Vogue Minis, just like this one, where he says that 2 plus 2 is 4 is just a perspective in white Western mathematics that marginalizes other possible values. It just actually is a kind of a word fun, of course. And but the post has been picked up by social justice activists who try to actually argue how 2 plus 2 could be anything, could be something different than 4. So also here we have a public attention to this question whether mathematics is factual or whether it could be called into question. And this is just tip of the iceberg, showing that mathematics is already being questioned, and that here the question what truth is already opened. I discussed the two episodes in more detail in a paper for IGME, which is linked in the description of this video below. And now I want to move on and come to mathematics education research. So what I did last year in 2020 is I searched for the terms fake news, post-factual, and post-truth, and for their German equivalents in 11 English and 6 German journals, and I yielded only 5 results. The most profound discussion of the topic can be found in Sheldon Hauge's discussion on the use of mathematics in fake news. For example, she says that it's very different to distinguish between uncertain, wrong, and deceptive uses of mathematics. It's hard to tell whether somebody did something as a mistake or on purpose, so to say. And she writes that some situations require a critical investigation of data, simplifications, assumptions, graphic representations, validity of conclusions, and how limitations in mathematics-based argumentation can be linked to an underlying agenda. In short, you could say that not only her solution, but also the solution of other authors who looked at this problem is that they advise that in the classroom we should develop a skeptical attitude towards uses of mathematics. We should expect biased judgments, and we should find the proper mathematical response. So yeah, and this is the recipe with which authors are proposing to confront post-factual uses of mathematics. So I will later argue that this is not sufficient. But to do that, I will have to address some more general thoughts on post-factualism. What helped me very much was a paper by McMullen, which was published very recently, where McMullen distinguished between 4 different kinds of post-factualism. First, he says, post-factualism can happen unconsciously. So we all might do that. We might agree to a fact, we might even agree to a statement, or we might reproduce a statement which is actually not based on facts, which might even be turning against facts. But we might do so unconsciously. And when people tell us that show us that we are doing this, we might be quite surprised that we did that. We might be ashamed of it, right? We might try to correct ourselves. So this can happen unconsciously without us knowing it. But then Macmillan is more interested in the three kinds of conscious post-factualism. And for example, motivational post-factualism, where people say, yeah, there might be truth out there, but I don't care to find out this truth, because for me it's much more easier, much more easier to just follow the opinion of a group I want to belong to. There is epistemic post-factualism, where people say that there might be truth out there, but I don't have the means to check this truth or to find it out. Yeah, because my means are limited. And then there's metaphysical post-factualism, which is most interesting for our case here. Metaphysical post-factualism assumes that it's not even possible to find truth, that every truth claim is necessarily biased, and there are certain interests behind that. And this is actually not something that comes from anywhere. This is something that comes from post-structuralism. So from this movement from France in the second half of the 20th century, which also has become very influential in mathematics education research and in the humanities in general. And this line of thought has also been imported. This has been shown quite explicitly. It has been imported into this whole post-factual movement as a kind of a legitimization why it's okay to think like that. The interesting thing is that the recipe we saw earlier, develop a skeptical attitude, expect a biased judgment, and find the proper mathematical response, this is not really countering this kind of post-factualism. It's actually reinforcing metaphysical post-factualism, because it's really repeating the same statements, yeah? The judgments are biased. You should always be skeptical. Yeah, this is the metaphysical position from which some kind of post-factualism arises in the first place. So it seems as if this recipe is not enough to face post-factualism. Yeah, we need something else. We need to grab the problem by its epistemological root, and for that, I propose to ask instead, how can an epistemology of mathematics conceptualize truth without falling back into realism? Now, what do I mean with realism? We have these old positions in the philosophy of mathematics, but also elsewhere, where we think that there's some kind of reality which is independent of human beings. So realism assumes that some objects exist independently of humans, and then we can get to know their true properties. There are some problems to this assumption. One problem, for example, is that we are limited by our senses. So how could we ever grasp reality in its full detail? Yeah. It's a very open question, and shows that maybe the whole idea of realism is not really working. But there are other problems too, but I can't address them now. In contrast, relativism assumes that truth and falsity, right and wrong, standards of reasoning, and procedures of justification are products of differing conventions and frameworks of assessment, and that their authority is confined to the context giving rise to them. And we know such positions also in math education research. For example, think about constructivism in learning. Yeah, there we have this idea that what is true or false depends on this framework of assessment that we have built so far, but which could change later. Yeah, we know that from the philosophy of mathematics, and we know that also from the humanities, especially from post-structuralism, which we have used a lot in also in critical math education. And what I say now is that this relativist stance is the one that post-factualism is building on. It has already left behind this realist position, yeah, which we also criticize. So if we want to face post-factualism, we have to do it in a relativist framework, and we have to say that if there is no human independent ground on which we can say what is true and what is not, we have to find an answer how anything could be true at all. Yeah. So what does it mean that something is true? This is the question now. On my last slide, I want to say that maybe there's a solution. I came across a theory which I find quite promising, but which has to be developed further. It all starts with Alistair Crombie, who was a historian of science, who showed in a 3-volume big book how science, over the course of history, used 6 styles of thinking. And Ian Hacking is a philosopher of science who took up this idea and understood these styles as styles of reasoning. And he proposed that they could create discourses in which objects get meaning, in which statements about them can be formulated, and in which these statements can be justified. So he took up these 6 styles from Crombie, which are the postulation style, which is closely related to mathematics, axiomatics and proof, the experimental style, modeling style, taxonomic style, statistical style, genetic style, and Hacking proposed to add an algorithmic style. And he was open to the idea that new styles might be there, not yet recognized, that they might come up, that other styles might fade into into oblivion. So all this is possible. The interesting idea here is that these styles are not human independent, right? They are made from humans, and still they allow us to argue that something is true or is not true. And this is the interesting solution here. So I had the idea that this is a good way to go forward. And I want to close by the question, how can mathematical reasoning be understood in such a framework and be explained within a relativist epistemology? So this is more or less an open project, but maybe I went a first step by publishing a paper on that in Educational Studies. And you find the link to that also in the description of the video. And maybe you're interested to learn more. Then I invite you to come to my discussion at the conference and maybe read my other papers on that. Thank you very much and have a nice conference.